Muchas gracias. Gracias a todos. Bien, pues vamos a dar paso a la segunda mesa redonda de la mañana. Los próximos 40 minutos vamos a hablar de algo fundamental, que es la inteligencia artificial y los centros de datos, un tema clave. Pero no solamente vamos a hablar de hardware, también vamos a hablar de consumo energético, soberanía digital, potencia de cálculo. En resumidas cuentas, vamos a descubrir cómo pasamos de lo invisible a convertirlo en soluciones tangibles, así que vamos a unir tecnología con viabilidad. Así que les paso a descubrir y a contar quiénes son los componentes de nuestra siguiente mesa. En primer lugar, Vikas Choudhary, Connectivity and Storage Business VP en MaxLinear, Miquel Moretó, Barcelona Supercomputing Center, High Performance Computer Architecture Research Area Director, Josep Capmany, Founding Partner en iPronics, y Roger Espasa, CEO de Semidynamics. Va a moderar la siguiente mesa Javier Cruz, Photonics Tech Lead en INECO-SETT. Un aplauso para todos ellos.
Yeah. Okay, hello, good morning. It's a pleasure for me to participate in this table to talk about artificial intelligence and data centers. Indeed, it's a very convenient day because I suppose that you know that yesterday NVIDIA announced that he was going to invest $5 billion in Intel. So the yesterday competitors are now partners. So this is a very interesting time. So let's go to begin. We are going to begin with Mr. Vikas Choudhary, who is Vice President of MaxLinear Connectivity and Storage. We have also José Capmany, which is co-founder of iPronics. We have also Roger Espasa, CEO of Semidynamics, Miquel Moretó, who is Director of High Performance Computer Architecture in VSC. Okay, gentlemen, let's go to begin because MaxLinear is one of the main play actors supplying devices for high-speed connectivity within data centers. Could you please elaborate what kind of devices could provide MaxLinear within this context?
Okay, thank you very much. First of all, it's a pleasure and an honor to be here. At a very high level, if you look at the data centers, at a hardware level, there are three components to it. There's the compute, which is the CPU and the GPUs. And then there is the networking aspect to it, which is how fast the data flows in and out. And then finally, memory and the different tiers of memory. These would be HBMs, which are closest to the compute centers, versus DDRs versus storage, hard disk drives or other kind of persistent storage. So today, MaxLinear is playing a critical role in the networking aspect, which is how fast the data flows in and out, and also in the storage, which is essentially making the storage more effective as compared to what the raw storage is. So those are the two places where we are playing a central role.
Okay, very interesting. Mr. José Capmany, iPronics is one of the reference in programmable photonics. How are you deploying this kind of programmable photonics within artificial intelligence and data centers?
Okay, thank you very much. First of all, again, also it's a pleasure to be here. So thank you for the invitation. Right, like Vikas has already said, there is a very important aspect in data center architecture, which is the networking. So the networking, as we see it, is composed of different layers. And if you look carefully to what has happened with data centers, well, data centers right now are able to manage an amount of traffic, and they will be, which is almost equivalent to the whole telecom network of some years ago. So that means that you need to be able to design and implement networking architectures that are layered. Up to several points, you will have to have a huge aggregated traffic. And the only way to manage that is with photonics. So it's very important to be able to develop a technology that is capable to do photonic switching and does this on an aggregated traffic basis. And for us, this is circuit switching, which has been very successful in telecom. It's probably the only technology that is able to handle terabit per second traffics, and also to do this in an independent, traffic independent format. And moreover, with the search of artificial intelligence and the need to interconnect a huge number, we are talking about hundreds of thousands of GPUs at a certain point. So this is the only way to do it. Now, to have a flexible interconnection scheme, you need programmable photonics, because integrated photonics itself, it's not enough. You have to be able to dynamically reconfigure your traffic patterns, to dynamically configure the capacity that is needed in the data center and the connection. So this is what we are developing in iPronics.
And when do you think about co-packaged optics?
Well, this is a sensitive question. Yeah. So I have to be politically correct. This is one of the options. Yeah, we'll see what happens with that.
Okay. Okay. Miquel, what do you think about the possibilities of we are doing in Europe about our capabilities to compete with United States and China in infrastructure or artificial intelligence?
Okay, so I guess you're referring to capacity?
Yes.
AI capacity?
Yes.
So if we want to compete, competing with the US and China is very difficult. Honestly speaking, we are far behind them. If you refer to capacity as just installation of AI hardware, I mean, this is something that can be done with money. So there's no problem, except if the president of the US decides not to sell NVIDIA to us, which has happened with other with other countries, and in the past, President Obama did this with China. So we are now in the process of the European Union is in the process of getting what they call gigafactories, AI gigafactories. These are these AI factories with over 100,000 GPUs. This is a large infrastructure, and I think it's a very good opportunity for us to be able to have few of them gigafactories in Europe, and to be able to have a first European hyperscaler that can compete with the other countries. Of course, the hardware there right now must be American, but there are companies like Semidynamics and others that maybe in the near future will be able to provide European hardware for European gigafactories.
This brings us to Roger Espasa. What we can do with RISC-V? Can RISC-V provide some kind of alternative so the microprocessor needed for artificial intelligence? What do you think about?
Well, first, thank you for the invitation to be on the panel. It's a pleasure. Yes, I think in the context of European sovereignty, RISC-V is the only option. It is my job to say it's better than everything else, but the reality is that what's good about it is that it's open. It's an open standard. And if you're in Europe, you cannot do x86, you cannot do ARM, or you pay a lot of money, and in any way you're not in control of your destiny. So the only option is RISC-V. Besides being the only option, it's a good option, right? So it actually comes with double benefit, and that's what we're doing at Semidynamics. We're taking the RISC-V technology, we've extended it. That's the third thing I would signal about RISC-V, which is anyone can decide, I want to do something different. I'm going to add this thing the way I think it's good, the way I think is going to be best for the software I want to run or for the AI I want to run. And that's exactly what we've done. We've extended it with a tensor unit. And this technology we're putting into silicon, and we hope to be supplying lots of racks to the gigafactories in the near future. Let me be vague about the about the dates. But we want to be one of, or the European supplier for those gigafactories, to be competing with a giant as big as the ones we all know that are in the US, right?
Okay, very interesting. Vikas, what technology are leading leadership of MaxLinear within this field?
So let's get back to the first picture that I painted across, other than the compute, where there are competing architectures and where we don't play right now. But we play in the networking and the storage space. So in the networking space, most of the data has to be transferred at this rate over the fiber optics, right, over the fiber. And towards that, one would need an electrical to optical or electrical to optical conversion. So there's photonics involved, and then there is DSP that essentially equalizes for all the loss that is happening over the channel. So we play a critical role over there in developing the next generation, what we call, all the way from, MaxLinear has a past history of developing this technology all the way from 25 gig, 50 gig, to 100 gig, to now 200 gig and beyond, per lambda, as they say, for per wavelength. And the signaling level has transitioned all the way from just pure NRZ, which is a bipolar signaling, to what we call now PAM4. Which is dissecting the signal in multiple levels electrically. So that's where we are playing a critical role in terms of networking today.
Okay.
In terms of storage, we are developing compression algorithms and security algorithms to make the effective storage go 10x or better. So that is where the key technology is being developed.
Okay. Very interesting.
In addition, although I did refer to and allude to that we don't play a key role in the compute, one thing we do is, the CPUs and GPUs, or for that matter RISC-V as well, or different competing x86 ARM or RISC-V architecture, they're not good at everything. And one of the things that we have figured out is that they're not very good at compression or encryption. So we developed these, what we call storage accelerators, that essentially offload data services, primary compression or decompression, and encryption, and therefore make the overall power consumption of the rack extremely effective. So those are the two places that we are playing key technology leadership role.
Okay. Jose, what are the main advantages of programmable photonics compared to traditional electronic FPGAs?
Okay.
In short, please.
Yeah, I don't know if this question has a right answer, and I will explain myself. I mean, the advantages of incorporating programmability to any technology come from reconfigurability and what it brings in terms of flexibility, cost reduction, and that has happened in electronics with the FPGAs, with the microprocessors, for example. And we hope that this will happen also in photonics. To put it simply, we want to advocate for the concept of software-defined photonics, where we provide a platform, a photonic platform, which is the starting point, but the real value is brought by the software. So the photonics layer has to be extremely cost-effective and also extremely flexible. That's the point.
And do you think that silicon photonics has...
Absolutely, yes. Silicon photonics is, first of all, is a standard technology, is moderately low loss. It's compatible, it's CMOS compatible, compatible with electronics. It doesn't amplify, that's correct. It doesn't lace, but this is no longer a problem because you can either interface chips or you can incorporate active parts by transfer printing or wafer bonding. Transfer printing is already being developed with.
And what do you think about to enhance silicon photonics with other, like barium titanate or thin film lithium niobate? What do you think about?
Yes, this is an option which again can be included into silicon photonics by transfer printing. The idea here is to bring speed in the modulation processes, because silicon can be fast in modulation, but it also brings losses. Any kind of silicon modulator will bring losses, and while lithium niobate and barium titanate for modulation and also for programmability brings fast operation regimes. But again, this technology is not yet developed to a point that it can become a commercial product. So
Okay.
it will take some years.
Miquel, what do you think about the interconnection of photonics within your framework?
So I come from BSC. BSC is the National Supercomputing Center in Spain. It's one of the European labs. And basically we have Moderador, our supercomputer, and the main advantage is that we have lots of compute power with a very high speed interconnect. But this interconnect is not the only one that we have. I mean, the machine has several interconnects for data management, for service. These ones are not that well known. The high performance interconnect is the most important one because it's the one that allows us to do parallel computing. And as a result, is one of the most expensive parts in the machine. It is something that people may not know, but Mellanox or whatever company provides this is charging us a significant part of the cost of the machine. Our machine doesn't have photonics interconnect. Next machine in 5 years, I don't know if we will have it. Should ask Jose. I think it's a very promising technology, but it's a technology that needs investment, needs time to develop, and we will see. We will see in 5 years for Moderador 6 if it is an option for us.
Okay. Roger, do you think that RISC-V is enough mature in order to be employed in very intensive activity regarding to high performance computing and artificial intelligence? Is plenty of maturity?
Absolutely. I mean, it's once you're past the point you can put Linux, you can do anything you want. Yeah, that's we're past this point probably several years ago, right? Android is being developed, and now it's a question of market adoption. And in fact, I wouldn't say all, but a large majority of the AI startups I know and companies doing AI that are not established from many years ago are all using RISC-V as the foundation. At the same time, it's a little bit unimportant, right? What's important in AI is to do tokens per second and to run the software, and the interface really today is Python or an NX. So there is a layer above all of this where the people using these machines for AI really don't care if you're x86 or RISC-V. Again, this I should be defending it, but what it gives us is the freedom to innovate, and it's more than ready. And that's exactly what we're doing. We're using it as a way to not have to reinvent the wheel, not have to create a compiler, not have to create a software stack, not have to, so lots of no's, I should be positive, but it's fantastic because instead of spending money in software that already exists, we benefit from the incredible software effort of the Linux community. Anything that runs on Linux will run on our device. So we don't have to answer the question, how are you going to overcome CUDA in your technology? I have something a lot better than CUDA. I have Linux, right? Or I have the help of lots and lots of people that have contributed to the Linux ecosystem, and with RISC-V running anything that runs on Linux, problem solved. So it's more than ready.
So do you think that we will see some GPUs based on RISC-V made in 100% Europe?
Ours, it will be a GPU based on RISC-V, 100% made in Europe with the help of some Taiwanese manufacturer.
Vikas, what could you elaborate more, the difference of your opinion between optical transceivers and co-packaged optics within your framework?
Right, right. So going back, optical to electrical conversion, there are two portions to it. There's the optics part, laser drivers or the transimpedance amplifiers there. And then there, of course, there's the DSP. And then the question is, how do you aggregate or disaggregate them? right? So when you combined the optics and the electrical together and put it in a module, it's called pluggable modules, and that is the de facto technology today. Right? Another way to disaggregate this would be to take the electrical, put it in the switch boxes itself, while keep the optics separate. That is called linear pluggable optics. Right? Yeah. And then finally, what's trending, and people may have different opinions about that, is called the co-packaged optics, which is take everything and put that in the switch boxes itself. And that is the co-packaged optics. And as you can imagine, you can put them on a time frame. The pluggable transceivers are the current technology. LPOs are being driven as, I would say, a transition. And then finally, the future, at least what it looks like right now, is the CPOs.
So the future, do you think that is CPO?
I think so. If we were to think about the gorillas in the town, when it comes to networking, it is NVIDIA's of the world, the Broadcom and the Marvell, and they all have demonstrated different levels of maturity in the CPOs. Right? And I think that is what it is tending towards. Will there be a space for LPOs and pluggable transceivers? Absolutely. But I think, to me, what it appears right now is that the future is tending towards CPOs.
Okay. Jose, how are you going to scale up the manufacturing of your optical switching systems?
Well, thank you. Actually, we have in the market a product which with a moderate low radix, which is 32 by 32, and this is just for the sake of. I mean, we sell and we have sold several units this year. But this will not be the mainstream product because hyperscalers and really want to start from 64 to 64. So that piece of equipment, this product is already on testing. So the chips are being fabricated, they've been measured. So this is being assembled. But the real need for hyperscalers is to go beyond that, 128 by 128 to 156 and more, because actually there's a logic behind that, no? And also because in the case of photonics, there's a strong competitor in terms of radix, which is MEMS technology, which is quite adequate for high radix, but unfortunately it's a little bit bulky and it's mechanical, so it has some. It's been tried tested by Google for several years, but we believe that the fully integrated optics with no movable parts is for us is the future. So the way to scale is reach like a 200 by 56 by 256 port by 2000. The roadmap is to have that by 2028, late 28 in the market.
Okay. Miquel, what kind of architectures are BSC currently researching about how to improve the performance of high-performance computing?
Okay, so Roger already kind of answered this question. The technology we believe in nowadays is RISC-V. Just to put you a little bit on perspective how we reached this conclusion, I mean, BSC was founded 20 years ago. We are a supercomputing center, but our main mission is to develop European domestic technology from the application down to the hardware. And what makes us unique in Europe, and I would say in the world, is that we are experts in computer architecture, in high-performance computer architecture. Since we were created, we collaborated with big tech companies from the US, basically, Intel and PowerPC and IBM, sorry, to have an impact on the next generation of machines. And this kind of collaboration will work very well. I mean, we are still collaborating with them, but you don't see a European machine out of that right now. After some years, thanks to the European Mont Blanc projects, we switched to ARM. ARM was a European company back then. We deployed the first HPC ARM-based cluster in the world. So this is something we did at BSC in the Mont Blanc project. But with Brexit and SoftBank acquisition, it was impossible to continue working with ARM to have a European solution, or it would be very expensive, as Roger already said. So the only alternative for Europe we realized was RISC-V. And basically we are fully focused on RISC-V. We have been working on it close to 10 years now. We have fabricated already 9 chips, the beginning very low performance and high power chips. And nowadays we just fabricated a chip in Intel 3 with Intel Foundry Services, thanks to the PERTE chip. And we see that this is evolving very quickly, and our bet now with RISC-V is to try to have an influence in this open standard. We are working in the vector and the matrix extensions, so trying to have an impact on the definition of these extensions, and also doing some prototypes with that.
Very interesting future, which is already a reality. Roger, do you foresee a role for photonics in the interconnection of RISC-V?
Well, I'm glad you asked me something about photonics so I can disagree and make the panel more interesting. I mean, if you see the first level of interconnects in the AI data centers, they're copper, right? So and the transceivers are extremely expensive, right? The companies making those transceivers are making a lot of money. So it is a problem. The cost of photonics is too high. And every time I talk to photonics people to understand how does it work, they tell me everything about their incredible chiplet that generates the signal, and then I ask, where's the laser? And the laser is hiding behind the booth, is big and bulky, and they'll tell me, no, but it's still complicated to integrate lots of lasers, the power of the lasers, where do you put it on the board, how do you, because you've got to feed those connectors with the laser. There has to be a light source somewhere, right? And the co-packaged optics may happen, but I think it's not flexible, right? It's so detailed. It is only for racks in the NVL72 style where the rack comes with a truck and it's finished, right? Lots of data centers want flexibility, want to be plug out the 4U, put something else, want to disconnect things. And the moment you start having a human disconnect optical things, it doesn't work that well. Certainly the CFP modules have been working really well, but they're expensive, right? So I see a practicality, right? Photonics is very delicate, and for highly integrated environments, yes. For environments that need maybe not the top data centers, but there are many other data centers that are not as sophisticated, it's more complicated.
Okay. Vikas, why storage has suddenly positioned so importantly within the framework of data centers?
Okay, yeah, great question. So I think if you look at the data centers and the hardware construction of it, the conversation always gets dominated by the compute platforms, which is fair, or by optics and transceivers, right? Having said so, if you look at the BOM of the hardware there, one of the biggest components of the BOM today is the HBM, which is the memory, right? But one of the big things that is happening now in the AI world is the transition from training to inference. Right? So the world is, the top 4 or 5 very CapEx heavy company that can do training. But eventually the business or the value of AI will be realized by inference, right? That is where the answers to all the complex questions will be coming from. Now, as this shift from training to inference happens, memory is becoming the choke point. It is not necessarily the compute. They're good enough, they're flexible, and more can be shoved in if you put more compute power there. But the choke point today is the memory itself and the different tiers of memory, whether that be the easy access to HBMs or the DDRs, or to far sitting out storage that thus far has played the role only of adding capacity. But going forward, what will happen is that one would need storage with the, so to say, the performance metrics that of cache, which is the closest sitting memory, let's say, that of the HBM. So storage has suddenly become extremely important. That's the first, because it is becoming an input to all the inference. So that's the first. The second, I would say, from a power consumption point of view, for every bit to be computed, there's 10 bits of data that is getting shuffled around. So from a power consumption point of view, it's extremely inefficient architecture today. And that needs rethinking, whether that be in terms of how the different classes of memory needs to be developed, or how storage needs to become a lot more effective, or finally, how we do the compression and move less data over this entire AI fabric. So what is happening with the onflux of inference, storage, and therefore the compression of data, and less movement of data for every compute that you do on a bit is becoming very, very critical. And then therefore storage, I think, is emerging and will be one of the central topics to be talked about in the next few years.
Jose, do you think that optical switching is a must for the volume of GPUs that need to be interconnected?
Okay, well, it is when you go up in the network layer. When you have to deal with aggregated traffic, it is actually yes. So I agree with what Roger has said before. It makes no sense to do a photonic interconnection at the lower level. We don't have photonic routers at our homes. So it's only in the higher layers of the telecom where photonics makes sense. And we have to be able to design an infrastructure that leverages each technology for what is good. And in the case of photonics, it's very fast, it's low loss, but you cannot ask photonics to do things that that electronics is already an excellent technology and unbeatable. So, it's
a niche. It's a niche.
Well, I would say it depends on what you consider a niche. For me, it's like if you have to provide networking solutions for something that is scaling up and it's increasing in capacity and it needs to be done, it's just another layer. So if you want to consider a niche, the technology that supplies the connection to a layer, then it is. But I think but with photonics, we can do more than that, but also always bearing in mind that you want to exploit the things for which photonics is good. Linear operations, broadband operations, and low loss.
Okay, Miquel, how is the relationship of VSC with universities and research technological center within this framework?
Good, so VSC is a research institution. Research means collaboration. So we are collaborating with everybody as much as we can. In particular with companies, we have bilateral agreements. We have many projects going on with them. Universities and research centers, we focus more on collaborations via European projects. That's basically it. University level, we have at BSc many PhD and master students. And then I would say we have a very interesting program for undergrads that are still not engineers. Then they can do, there is an international program for summer internships at BSc that I think it's really appealing to them. Finally, now, as I said at the beginning, we are starting these European AI factories that we will get around 1,000 GPUs at BSc. And as part of the project, our mission will change a little bit because we will provide support, technical support, so access to machines and technical support to SMEs, to small and medium enterprises. And this means that these companies will be exposed to AI hardware, AI models. We will train them, and once they see that this is useful for their products, they will go to production with their own cluster in the cloud or acquiring the machines.
And do you have enough talent available, or
So here I have a controversial
so we have
opinion.
also a problem in this area.
My controversial opinion is that I have a lot of talent. And every week I receive emails from students that want to come to BSc. My problem is that I cannot retain it. That's my big problem, because after 1 or 2 years, they receive very good offers from companies like Semidynamics, and they jump to industry. But there is a lot of talent, and young students are great. They know a lot, and they are the ramp up is super quick. The pity is that they leave.
Roger, is Europe investing enough in artificial intelligence?
Well, no, of course not, right? Look at what happens.
Never is enough.
No, but look at how the US operates, right? And let's take an example, it's public. Microsoft puts some billions in OpenAI, OpenAI turns around and then signs a contract with Microsoft and says, I need 10 billion of hardware from you. So the same dollar is going in circles and creating a positive effect where now Microsoft has a real contract and go to the bank and provision that hardware, and that hardware then ends up benefiting NVIDIA or whoever supplies that hardware. So we're not investing enough. It was a very good announcement, the one from ASML investing in Mistral. This is our first little step in the correct direction, but we have one little flower. The US has a whole, a whole set of trees, and Anthropic is working with Amazon and Google. So no, absolutely not. Furthermore, all our investments, and to try to spice up the coffee break, end up in the research sector, right? We create centers of excellence, networks of excellence, pilot lines, and and then coordination between one and the other, and more and more. And if you scratch, it's all public research, which is fantastic. But if we want an industry, we have to put money also on the industrial side. We have to create demand. And to create demand, there has to be someone that purchases things, right? And that's how the US does it. There's a demand, lucky for them, now they have private demand, they have users actually paying for ChatGPT, right? So that's a luxury they have. If Europe wants to catch up, investing in basic research is fantastic, but that's what we've done all our life. And all this European taxpayer money goes to a fantastic research system, which benefits the United States companies. So we have to use our taxpayer money to come back and create demand for European technology so that we have a European. So my answer is confusing, is we do need more investment, but the investment should not be in the form of more research, more basic research, more grants, more networks, more blah, 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 blah. It should be in creating demand for European products, be it photonic switches, be it GPUs, be it storage, whatever that may be, create demand for European technology. And that's where the European Union should be focusing the effort.
Okay. Gentlemen, we are about to finish, but my last question, let me to address to Vikas. MaxLinear Spain is doing a great job. So what fit the place of MaxLinear Spain within the strategy of the MaxLinear in general?
So let me actually take a step back.
Very short, please.
Yeah, no, very short. I'll just make it, I know the time's up. Very short. I mean, I've been fortunate, and it's a great pleasure to be associated with Valencia for the last, I would say, 10 years. Javier is sitting out there from Analog Devices when I started my association here with Valencia in the semiconductor space. And now with MaxLinear, it plays a very significant role all across the stack, whether that be the semiconductor development for developing all the high-speed interfaces, or the software stack on top. So I think with the talent, university talent that we have, great English speaking, and very, very high-end university graduates that we can actually recruit from, MaxLinear Spain plays a very, very central role within MaxLinear today. So.
Okay, thank you very much, gentlemen. It's been a pleasure, so very inspiring. So thank you.
Thank
you.
Muchas gracias.